Okay, this is section 1-3, part B, starting at example 6. So we're going to be solving for a variable this time. And we can use the property of equality to solve an equation or formula for a specific variable. Example 6 is talking about geometry. We have a cone, and we want to solve this cone for the slant length. And we have our formula, S equals pi RL plus pi R squared. For S is slant, the surface area, pi is pi, R is radius, and L is the slant length, plus pi and our radius squared. So we want to solve this formula for our slant length, which is the L. And S, remember, is our surface area. So we need to rearrange this formula to get L by itself so we can solve for it. Okay, so let's start solving for our slant length, or our variable L. So on the left we have S, our surface area, and on the right we have pi RL plus pi R squared. So the first thing we need to do is start getting rid of this pi R squared. Move it to the other side to start whittling it down just to our L. So if we notice it's plus pi R squared, we need to subtract that from both sides. So what we do to one side, we have to do to the other. So on the left we get S minus pi R squared equals pi RL minus, or plus pi R squared minus pi R squared. On the left, we just leave it as S minus pi R squared equals pi RL, because the plus pi R squared minus pi R squared drops out. Okay, so now we need to start looking at the right side, because there's pi RL. Pi and R are multiplied to the L, so what we need to do is divide each side by that pi and R to get rid of that and get L by itself, because what we do to one side, we do to the other. So on the right, or on the left, excuse me, we have S minus pi R squared over pi R equals pi RL over pi R. And when we cancel, we're left with S minus pi R squared over pi R equals L. So that's how we find the slant length of a. Alright, now let's look at example 8. So we're on page 23 of the textbook. So this time we are going to solve a word problem. It is often necessary to define a variable and write an equation. So then we solve by applying the correct properties of equality. So we have here, home improvement. Josh and Pam have bought an older home that needs some repair. After budgeting a total of $1,685 for home improvements, they started by spending $425 on small improvements. They would like to replace 6 interior doors. So 6 doors they want to replace. What is the maximum amount they can afford to spend on each door? So looking at this, it says explore. Let's have C will equal the cost of each door, the cost of the door. Replace it. Now let's write a plan. So we'll write and solve an equation to find the value of C. So we know the number of doors. We need 6 doors times the cost times C for each one. So I have 6 times C, which is the cost to replace each door, plus $425 that they have already spent on previous expenses. And this equals the total amount of money they have, which is $1,685. So we can read this out. 6 number of doors times the cost to replace each door plus what they spent has to equal $1,685. writing this as an equation, we have 6C plus 425 equals 685. Now we need to solve for C. First thing we need to do is subtract 425 from the right. 6C equals 1685 minus 425 is 1260. 6C equals 1260. Divide each side by 6 to get that C by itself. C equals 210. So they can afford to spend $210 on each door. Okay, so when we examine this, the total cost to replace 6 doors at $210 is 6 times 210, or $1,260 is what they're spending on the doors. All right, so when we add the other expenses, we can see that the total home improvement bill is $1,260 plus $425, which equals $1,685. So we know that our answer is correct.